First of all, let's do our framing part. Basically, let me draw the figure, diagram, whatever that will help to solve this problem. So we have a soft ball, initial velocity given 15, and the direction also given 45 degrees below the horizontal. So basically, approximately this is a v1 initial velocity 15 meter per second, and below the horizontal 45 degrees. So this is the initial direction of the softball, and someone delivers some impulse. That's why this softball changes its direction. So after impact, after applying the impulse, we know its direction. It's given velocity 40 meter per second and above 30 degrees above the horizontal. So basically it will be moving in this direction approximately. I especially draw a bit longer because velocity is 40. Initially it was 15. So I'm trying to scale the vector. So this is a v2, let's call it 40 meter per second, and the direction, this is a 30 degrees. This is what we know. So first question, determine the impulse delivered to the ball. So we should find the impulse. So this is a framing picture diagram that we know. First part. Second part, let's plan. What we can plan. So what we have a mass, we have velocity. It means we know its momentum. P is a momentum, which is basically mass times velocity. Initial momentum and the final momentum also given, because velocity given. Directions are shown in this figure. What else we can say? We can ignore the gravity here, because when you deliver impulse, it's very small time. That's the effect of the gravity here we can ignore. Basically gravity equal to 0 for this problem. What else? No friction. And the momentum conserves here. Basically initial total momentum should be equal to final total momentum, conservation of momentum, because momentum conserves in any case, elastic collision, inelastic collision. That's why we can apply it. We are not sure about energy conservation, mechanical energy conservation, but we exactly know that momentum conserves. That's why we can apply. What else we can plan in order to solve this problem? So momentum, which is vector, maybe we can use vector additions. Maybe it will be useful. I think this is enough to solve this problem. Now let's come to the solution part. Let's try to solve this problem. So momentum conserves. So basically initial momentum, someone is delivering, applying impulse, which is unknown, which we should find. We know that impulse is vector. We don't know its direction. So that's why I'm writing in general form, in vector form. Will be equal to final momentum. Let's call it P2. P1 direction is given here. The magnitude of this momentum equal to mass times V1, which is also given, mass 0.2, initial velocity 15. So magnitude of the initial momentum equal to 3, basically 3 kilogram meter per second. Now let's come to the final momentum. Mass, same softball times final velocity mass 0.2, final velocity 4. So magnitude of the final momentum after impact equal to 8 kilogram meter per second. So numerical value of momentum, initial, final given. Directions also shown in this figure. We need to find impulse. So the impulse from this formula, from this equation, equal to final momentum in vector form. We should subtract initial momentum in vector form. That's all. Further is just the addition of two vectors. Very simple. This is a P2, as you know, as shown in this figure. P1, we should add negative P1. This is a negative P1. So basically I'm using triangle method here. Addition of these two vectors, roughly this is a resultant vector, which is impulse for our case. And as you see, direction is approximately upward. So we can apply cosine theorem in order to find the numerical value of this impulse. So this side of triangle equal to 8, this side of the triangle equal to 3. This angle will be equal to what? We know that if we draw horizontal line, if we draw the horizontal line, this angle is 30 degree. This angle, so here it was 45. Yes, so total angle here 75. So let me draw it again separately. So we have approximately this kind of triangle. I didn't pay attention to the scaling for now. So this side is 3, 8, angle between these two sides 75. We should find this part of the diagonal, length of the triangle. So we can apply cosine theorem in order to find the length or magnitude or numerical value of the impulse, this part. Cosine theorem is, you know, square root 3 square plus 8 square minus 2 times 3 times 8 times cosine 75 degrees. So approximately it will be equal to, let me use my calculator, 3 square plus 8 square minus 2 times 3 times 8 times cosine 75. So answer is 7.78. So this is the impulse, kilogram meter per second. So we found the numerical value, magnitude of the impulse. But this information is not enough, as you know, because impulse is a vector. So we should find its direction, exact direction. For this reason, I think we can find this angle, first of all, in order to describe its direction. Here we can apply sine theorem from geometry. So it states that 3, this side divided by sine of the opposite angle, which is unknown, and the impulse, which is 7.78, divided by sine of the opposite angle, which is sine 75. From here we can find angle, and this angle will be equal to 3 times sine 75 over 778, and in terms of angle it will be equal to 21.8 approximately. So we can round it 22 degrees. Let me round it 22 degrees. So this angle is 22 degrees. This angle, it was given 30 degrees. So total angle is horizontal, above the horizontal, will be equal to 22 plus 30, 52 degrees. So this is the direction of the impulse, and this impulse equal to 7.78, and above the horizontal 52 degrees, and this is the total answer. So this is end of our solution. Now we need to check it. How we can check it? Initially, before impact, softball was moving downward, approximately downward here in this direction. After impact, it changed its direction upward. So it means we know that roughly impulse was given upward, general direction, maybe with some angle. And here what we got, we have impulse also direction upward and to the right a little bit, which is I think reasonable, more logical. So I think our solution is correct after checking our solution result.